Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 24 in our new Arduino tutorial series. I will need you to pour yourself a big cup of iced coffee. I will need you to get your eLego Super Starter Kit. If you don't have one, you can click on the link in the description below. Get one of these, 35 bucks. It's got a boatload of components and it has all the things you need to go through this entire tutorial series that we're putting together. Okay, in today's lesson, we are going to learn how to use the passive buzzer. The last two lessons we talked about adding sound to your Arduino project using an active buzzer. And the nice thing about an active buzzer, you just apply a signal and it buzzes. The disadvantage is they cost a little more, and the other disadvantage is you don't have much control over tone. Luckily, the eLego kit contains both an active and a passive buzzer. The way you can tell the difference is, let me get out of your way. The active buzzer has a little bit of a black tape on the bottom, and the passive buzzer has got a green board that you can see. So we are going to get the passive buzzer. Make note that the polarity does matter, that if you look carefully, I don't know if I can get it to show, one of the pins on the top you can see is labeled with a plus. The plus needs to go to the plus and the other one needs to go to ground. So I'm going to come from the one that doesn't have the plus symbol on it, and I'm going to hook that up to ground, and then the lead that has the plus signal, I'm going to come over and I'm going to connect to pin 8. All right, to use the passive buzzer, the thing that is different about the passive buzzer is to make it buzz, you've got to turn it on and off and on and off. And so let's just do that as simple as possible. We will come over here to a suitable window. I think this is probably suitable. And let me come over here and let's try to get this going. So let's get our code going. We have int, we have a buzz pin, and what is buzz pin? We hooked it up to 8, so we will say equals 8. And then we are going to need a, let's call it a buzz time, and we will set that equal to 1. And then we will set a buzz time 2. 2 is going to be equal to 2 milliseconds, so we can kind of try different tones here. On our void setup, this should be pretty easy. We are going to do a pin mode on buzz pin, which is going to be an output like that. And then in our void loop, let's just do it as simple as possible, and let's just see if we can get this thing to buzz. So we are going to do a digital write of buzz pin, and we are going to do it high, okay, and then delay by buzz time, and then digital write buzz pin low, okay, and then delay by buzz time. All right, so this is just going to turn it on and off really quickly, and let's see if we can hear it. Yeah, okay, so we've got a tone. All right, so let's see if, I hope you can pick that up good. Okay, let's change it to buzz time 2, and let's see if we can perceive a difference. All right, change that to 2 and 2, come over. Yeah, definitely. Okay, let's change it to buzz time. Let's change buzz time 2 to 3. Definitely getting, almost like we're getting notes here, right? I'm still perceiving that to be a note. I don't know if you are. I mean, it's still like would be a real frequency. Okay, I'm still hearing that. 6. 7. I'm trying to 8, 7, 8. Let's go all the way until it just doesn't sound like a good buzz. That's getting pretty close to the limit because I'm almost starting to hear it click there. 10. Okay, I'm going to set my lower limit because it doesn't seem to be getting lower. It's just kind of stuck. So I'm going to say the lowest good tone is a 10 millisecond delay. So I'm just making note of that. Let's go the other way. Let's go back to 1. Now, to look higher on the high end, the problem is we can't go less than 1 millisecond. So you're going to learn an incredible thing today, and that is there is a different delay that you haven't heard about yet. It is delay microseconds. And look at that, it lights up happy orange. So now we're in microseconds. So 1 millisecond is 1,000 microseconds. So let me change this as well. Delay microseconds. Okay, so 1, and we are on buzz time 2. Okay, 1 millisecond would be 1,000 microseconds. So if I download this, I haven't really changed anything. Okay, you see it's the same, but now I'm in microseconds. So let's go lower, 900 microseconds. 800. 700. I can still hear it. 600. 500. Let's go all the way to 200 and see if we can still hear it. Yeah. 100. Ooh, that was a messed that up. 100. Okay. Let's go 80. Okay, I can hear it. Just would be interesting. See how low of a number that you can still hear. Like I can hear 80. But you've got to do it yourself, not over the microphone. I can hear 60, 50. I can barely hear 50, 40. I can't hear 40. So let's go back. I think 60 I heard pretty well. Okay, so guys, you see how you can get the I'm going to turn this off for right now. You can get kind of the different tones that you want. And what did we say that you go from 10 milliseconds, which would be 10,000 microseconds, and you go from 60 microseconds to 10,000 microseconds, and that's kind of the range that you can get good tones that you can detect. And so you can see that by setting this delay time, you can get the tone that you want. All right, now this is your homework. This is your homework. And let me get a piece of paper over here because I'll give you a little hint to get started. I want you to get your potentiometer. All right, I want you to get your potentiometer. Maybe I should come back over here to full view of this. Okay, I want you to get your potentiometer, and I want you to set up a circuit where the tone that you get out will be, if you're all the way to the left, I want you to have a tone that has a 10,000 microsecond delay. And then when you're all the way to the right, I want you to have a 60 microsecond delay. All right, so that is your homework assignment. Go off and build the circuit. I will give you a hint. In order to do this, you are going to have to do some math. Okay, you're going to have to do some math. Go do the math and then come back here and then we will work on this together. Okay, guys, did you figure it out? Did you do it yourself? You're not just cheating and watching me do it, are you? Okay, so let's see how we would do this. What do we start with? Let's do the math, okay? Let's do the math. So we are going to come here and we are going to draw a graph. And I hope you can see, yeah, I think you can see what I'm doing. We're going to draw a graph. And what we know is that this is pot val, this is the value that we're reading off the pot, and then this is tone. Okay, now if we're all the way to the left, we are at 0, and at 0 we want to have 60. So our first point is for a pot val of 0, we want a 60 microsecond delay. And then out here at 1023, for a pot val, which is all the way to the right, we want a 10,000 value, okay? And then we want a line in between there, like thus. So what do we need? We need the equation of the line where we can take pot val and come up with tone. Well, how do we do that? Let's go through this. M is equal to y2 minus y1 over x2 minus x1. That's the slope of the line. But in our case, that is going to be 10,000 minus 60 over x2 minus x1, which is 1023 minus 0. So our slope is going to be, I cannot do math in my head very well on camera, so 10,000 minus 60 is going to be 9,940. 9,940 over 1023. That is the slope. Now what do I know? Y minus y1 is equal to m onto x minus x1. That is the point slope form of the line. We have the slope, we have the point. Which point do we use? We could use either point, but this one would be easier, I do believe. So what we are going to say is y minus y1, which is what? 60. Y minus 60 is equal to the slope 9940 over 1023, and then times what? X minus x1. What is x1? x1 is 0. So what do I have? Y is equal to, this is going to be 9940 over 1023 times x, and then we've got to add this 60 back over here, plus 60. Now we can put it in terms of the variables that we actually used up here, and we can say that tone is equal to 9940 over 1023 times pot val, and then close your parentheses there, and then plus 60. That is the equation that we want to put in. All right, let's get this thing hooked up now. Okay, let's get this thing hooked up. We've got the, we're going to hook the tone to pin 8. Hopefully okay, let me do something here to get that thing to be quiet, because that is going to be annoying if we sit here like that. Okay, so I got that turned off. All right, now we've got to hook the potentiometer up. Do you remember how to hook the potentiometer up? Well, you've got this side that has the two legs. The top leg, or the left leg, we are going to hook to 5 volts. And so there is a 5V pin on the Arduino we are going to hook there. Now we need to take the other top leg, okay, the other top leg of the potentiometer. If you have a different potentiometer, we're hooking up just the outside legs. The other one is going to ground, and I have another available GND right by the 5 volts, so I hook that up like that. Now, the center tap, which in this potentiometer is on the other side, we need to hook to, let's say, a 1. All right, so now let's come in and let's write some code. I'm going to come up here, and my buzz pin is still going to be 8. I'm now going to have a pot val, which I'm going to read, so I don't need to put, sorry about that. Let me come over here where you can see what I'm doing. Okay, so I've set buzz pin to 8. Pot val I am not going to give a value to because I will read that from the potentiometer. Then it looks like I have already done my pin mode. My pin mode is buzz pin output. And then I don't think I need the serial monitor this time, so I will not turn that on. But I do have a pin mode. And I also need a pot pin up here, so I'm going to say int pot pin is equal to, what did I say that was? A1. It's connected to A1. And so now I need to do another pin mode, which is going to be pot pin, and that is going to be an input. So I now have my pin modes done. And so this I can probably use, no, I'm just going to, okay. Then we also need our variable tone, okay? And so I am going to say that I have an int of tone, and I'll say tone val because it looked like tone was a reserved word, tone val. And so I come down here in the void loop, and what do we need to do? Well, we need to read the value from the potentiometer. How do we do that? Well, pot val, which is the variable we want to put it in, is analog read of what? Pot pin. So this is going to read the value from the potentiometer. It's going to be between 0 and 1023. Now I need to calculate tone val, T-O-N-E-V-A-L, and that is going to be equal to what we put over here in this equation. Let's get that out of the way and let's look at this equation. Tone val is going to be equal to, open parentheses 9940 period, don't forget the period, point divided by 1023 point. All right, and then that is going to be multiplied by times pot val, and then we're going to add 60 to it. And that is just according to this equation here. Let me just show you that equation again. Okay, the tone val is 9940 divided by 1023 times pot val plus 60, which I think is what we have done here. So we'll come back over here. That's tone val. Now what I want to do is I want to digital write buzz pin high, and then for buzz time I want that to be tone val. And then we take buzz pin low, and then we're going to do tone val again. So you see I'm going up and down, and what is the delay time? It's tone val, because that's what I calculated, and I did that based on when we went in there and listened. So now we are going to download this, and we are going to see if we can control the tone by doing this. And remember, all the way to the left we should hear something, all the way to the right we should hear something. So let's see what happens here. Are you ready? Man, I did a lot of coding really fast, so we're going to have to hold our breath this time, okay? Here we go. Where is my mouse? Oh no, what did we do? We forgot to hold our breath long enough and squinch our face up, and we forgot to put our semicolon after this command. So this time, everyone, I need everyone to hold their breath. Oh, okay. Look at that. We are getting a tone. Do you hear that? Boom. Okay. We created a tone generator where the tone, that is a particularly annoying tone. Okay. We created a tone generator where the tone is set by where the potentiometer is. And we did that by determining the endpoints by our own hearing. I really think this would probably work better if we did it over a smaller tone range, like maybe not go all the way up to this extremely high pitch. So you could do this again using different endpoints. Okay, guys, so we're kind of starting to try different inputs and different outputs. The input is still the potentiometer. The output now is the tone generator. I'm going to unplug that. The output is the tone generator using the passive buzzer. You can see that the tone could be set by all types of different sensors, not just the potentiometer. Okay, guys, I hope that you followed along with this. I hope that you did this by yourself without just copying me. On these homework assignments, you're really supposed to do them before you watch me do them, because that is the way you learn. All right, this is Paul McWhorter from TopTechBoy.com. Think about giving us a thumbs up. Think about subscribing. If you subscribe, make sure that you ring the bell so that you get notifications. And think about sharing this with others. Paul McWhorter from TopTechBoy.com. I will see you guys later.